So the last problem that you had is like the lab. So yesterday we spent a big chunk of our day in class here working with our lab and doing the lab calculations. And as a result of that, we end up with we basically end up with the data table that looks very, very similar to what you had yesterday. So to highlight a couple of things, we are working with an acid here. And so our data table, we have the molarity of the acid, and we have a starting volume of the acid, and we have an ending volume of the acid. So that's going to be our acid information. And we also have a base, which in this case is CaOH2, calcium hydroxide, and that's present here. So this is our base information that we collected. So this style problem is very similar to the last style problem that we did, except there's one added step, and that added step is calculating the volume used. So step number one is calculate volume of the acid and base used. And just like we did yesterday, that would be a subtraction issue. So I'm going to start with my acid. And so I'm going to take the 42.92 milliliters minus the 28.90 milliliters. And that will give me, let's see, 42.92 minus 28.90 gives me 14.02 milliliters. Now, yesterday, you definitely noted that you had to convert that to liters, so I'm going to do that right away. 14.02 milliliters. We know that there's 1,000 milliliters in 1 liter, so that gives me 0.01402 liters of acid that we used. The second thing that we did yesterday is we calculated the amount of base that we used. So I'm going to do that here, which is 29.84 milliliters minus 16.86 milliliters. So 29.84 minus 16.86 gives me 12.98. And so 12.98, I'm going to convert to liters right away, just like I did up above for the acid. And so that's going to give me 0.01298 liters. So that's our first step. So the second step is very similar to the first step that we did in the last problem. So we're going to go ahead and do that right away, which is because we have more information about our acid this time, we are going to calculate the moles of acid. And so if we calculate the moles of acid, that is going to be a molarity problem. So molarity is equal to moles over liters. So in this problem, we already know the molarity of our acid. We were given that up above here, so that's going to be 1.50 molar. And we just calculated the volume of the acid that you used. So I'm going to use the 0.01402 liters. So when I plug this into my formula, which again is moles over liters, I have the 1.50 molar is equal to moles over the 0.01402 liters. So just like we did a little earlier, we're going to multiply both sides by the volume. So 0.01402 liters times 1.50 molar will give me the moles of my acid. So 0.01402 times 1.50 gives me 0.02103 moles of the acid, which in this case is HCl. So that's step 2. Step 3 is going to be to convert moles of acid to moles of base. And so when we do that, that's our stoichiometry problem. So I'm going to take the 0.02103 moles of hydrochloric acid, HCl, put it over 1. And now I need to determine my mole ratio. So if I go back up to my balanced chemical equation, I see that 2 moles of my acid is equal to 1 mole of my base. So I'm going to write or record that it's 2 moles of HCl for every 1 mole of my calcium hydroxide, which is my base. So I'm going to set this up so moles of HCl cancel out. So I'm going to put 1 mole of calcium hydroxide on the top and 2 moles of HCl on the bottom. And then I'm going to solve that. So I'm going to take the 0.02103 divided by 2. And my answer here is going to be 0.010515 moles of calcium hydroxide, or CaOH2. So that's going to be my answer for that step. And then our last step here is to calculate moles of base. So that is still going to be a molarity style problem. So molarity will equal moles. Hold on a second. So moles and then divided by volume. Now in this problem here, our volume that we used is for the base is the 0.01289 or 98. So we're going to drop that down here. So that's 0.01298 liters. And we just calculated the moles to be 0.010515 moles. And that's going to come from right there. And then our last step here is to actually throw this into our molarity calculation or molarity formula. So molarity is equal to moles over liters, which is going to be equal to 0.010515 moles over 0.01298 liters. So I'm going to take that and divide that out. And the molarity that I'm going to end up with of my base is going to be 0.081. Nope, I lied. Hang on. 0.808100924 something 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 something. Now sig figs here for this problem, and this is something that I did notice a little bit yesterday, is that some people wanted to round like at their volumes and be like 0.014 or 0.013. Don't round anything until you get to the bottom or the end, and then assess significant figures then. So if I'm looking at the data that I collected, all of my volumes had 4 sig figs. My molarity that I was given had 3 sig figs. So that tells me that my final answer, my final molarity, needs to have 3 sig figs. So the molarity here is going to be 0.08 or 0.810 molar. In this case, it's going to be CaOH2. So this is our final answer, and that's the work that you have to show to get there. Questions? Okay.